Ladies and gentlemen, welcome. This is episode 8 of the Efficiency Equation podcast. And last week we had a dive into OEE. And this week we're going to continue on with the introspection that great plant managers do. And we're going to help you dive deeper on the topics that enable you to make better decisions at your plant and to increase the efficiency and output and the overall happiness of your company and your plants. So I'm welcoming again our co-hosts today, Eugene and Konstantin Paradisov. Welcome, you guys.
Thank you.
Thank you.
So we are diving into two more acronyms today, and I'm just going to hold off. I'm not going to tell you what they are yet. This was just a teaser up to now, but yeah, let's kick off by going into what are some of the key questions that plant managers should ask themselves about how their current operations are doing. Okay, because what we're looking to do is we want to go a step beyond just equipment efficiency, and we want to optimize things even more. So what are some of these questions?
Sure. So one of the questions I'd say the plant managers should ask themselves is, are we experiencing high rate of product defects and rework that affects our costs? And if you find that the answer is yes, you will definitely benefit from looking into RFT, right first time metric. And we'll talk about what that is some more a little later. The other question you should be asking yourself is, do we frequently miss delivery deadlines and fulfill customer orders late and have some unhappy customers? And if the answer is yes, you will greatly benefit from looking into OTIF metric, which stands for on time and in full. You would also ask yourself a question about, do we have significant variability in the production processes that affect quality? And if the answer is yes, again, you want to look into RFT, right first time. A couple of other things is you should ask yourself, do you have trouble aligning your production schedule with the delivery schedule, resulting in overproduction or stockouts? And if the answer is yes, again, the answer is look at OTIF, on time and in full. You'll benefit from that. And then lastly, both RFT and OTIF help with cost. So if you have high costs due to penalties, expedited shipping, excess inventory, any of that stuff, you'll benefit from looking into both RFT and ODIF.
So Eugene, what are some of the challenges with RFT and OTIF if we want to dive deeper when it comes to liquid manufacturing?
The bulk liquid manufacturing has multiple processing stages, obviously, and each stage you need to know whether that particular stage of the process is done correctly. Just looking at the equipment cannot be enough and tell you that it was done right or not. So certainly you need some quality samples, you need the lab to be involved to determine if it was done right. And in some cases, you need to have multiple quality samples, right? So you can deliver the quality samples to the lab with certain regular intervals. You end up with multiple samples, and those samples provide different results to the lab. So the challenge in that case is to determine how you're going to go about detecting whether you did the right first time on that particular process, on that particular product or not. So that would be one challenge, making sure that whatever your process is, however you configure your process, really reflects the RFT, whether it was done right the first time or not. So that would be one thing for the RFT. If we want to jump through RFT, other things about RFT right now, we could do that.
Okay. And what's the situation if we get past the measurement challenge with RFT? Then what are some of the key challenges that contribute to the failure to do things right the first time?
Well, one of the things you could talk about is process control and consistency. How you control for the multiple stages of the process. There could be many different things that you consider, like mixing, heating, cooling, filtering, uh, bleaching. There could be many different stages. How do you maintain accurate and consistent calibration for your equipment to ensure that all those stages perform well? So the calibration of the equipment and consistency of the operation of the equipment plays a big role in defining whether you're going to be doing good on your RFT measurements or not. So that's one thing.
One of the things that we see at the plants is that the equipment malfunctions periodically, and the underlying description that comes from the operators is the same. So there are same types of failures reoccurring at some interval. And so that plays into RFT big time. You can say that maybe with improved maintenance, they can minimize those reoccurrences. But in bulk liquid manufacturing, you have a lot of piping. And through that piping, you pump all your liquid product. So obviously, one of the issues that we see from time to time is when there is some kind of stoppage at the pipe and the product cannot be pumped. And they call it frozen line, and it doesn't necessarily mean that it's cold temperature frozen. It just means that nothing can get through, and then they have to take certain action to get through there. But this goes back to process consistency. So you have some of the same issues reoccurring. And yes, maintenance people are doing their thing, but still, this is a great contributor to RFT fluctuations.
Then you have raw material quality that plays into measuring how well you can produce your products and be right the first time that you make them. Uh, Sometimes it's very hard to control what the quality of raw material is going to be. So you have to make sure that whenever you receive the products that's going to be used further in manufacturing, that you have very rigorous and strict testing to make sure that the products are of the quality that will satisfy your process. You have to make sure there are no contaminants that potentially can deviate from your good process from achieving good results during the quality testing. There could be other things like presence of odors or color being off, and some of the things can be fixed during the manufacturing process, some cannot. So you have to be really good with controlling the quality of raw materials, which then leads, of course, into the actual testing and sampling while the processes are running, to make sure that not only your raw material is good, but also during the actual process of making the product, you are good in staying on top of taking the quality samples and testing them for critical uh, characteristics that will allow you to ensure that you will achieve RFT, meaning that the products coming out will be deemed right the first time and will avoid going through some adjustments or rework.
To add on the quality testing and sampling, some of the stuff that we see in real life is it's not obvious, but you would think, right? If you have a lab, then the lab should do their job and analyze the samples in the best way possible and get you all the information. However, what may happen with quality in particular, like the testing and sampling itself, is there's two things. One is representative sampling. That means if you take a sample mid-run or at the end of the run or in the beginning of the run, that affects the results and affects how well the results can be used to interpret what the rest of that batch looks like, right? But what happens is the people that may take that sample don't necessarily pass the correct information to the lab that does the testing. So then the lab might not know the correct information, whether that's mid-run sample or end-of-run sample. So there's that. Miscommunication may lead to different results. And in some cases, where operators feel like it may be taking too long for the lab to analyze their samples, they then request from their management to have permission to test some of the simpler stuff themselves. So they would take a sample, they would come into the lab, and they run some basic tests on their own. And when that happens, that introduces noise into the system, because now you have operators doing tests, and not all of them perform the same test the same way. And so you again might end up with some results that are not as thorough as they could be. So the quality testing and sampling in itself might be an issue depending on who does this and whether the process is fully reproducible and repeatable.
Yes, and as you talked about the operators taking some of the quality control work onto themselves by performing some simpler variations of tests as they go along with the process. The important part here now is the next potential point in RFT to look at and to make sure you're on top of is the actual human factor. Which we go back to a lot of in many of our podcasts, right? It's the to ensure that all your operators and lab technicians are well trained on the procedures and operating procedures of the process, to make sure that they do the right thing as they take quality samples, as they analyze them, uh, the timing of the samples, as Konstantin mentioned, like when do you take them? Do you know that you're doing it at the right time? All of those things are important. So the training and making sure that people follow the standard operating procedures prescribed for the process is key to maintaining quality and achieving good score on the RFT measure.
So how do the environmental factors play into this?
We had an example of this. So with one of the customers, the raw material is sitting outside of the plant before it's taken in for processing. And the customer staff noticed that depending on how hot it is outside on that day, they get different quality results. So when you have large batches of product arriving, in some industries, you have these tankers that are fully heated and nothing changes. In other industries, where you have, for example, fresh fruit delivered to you, and that fruit needs to be processed, that fruit is delivered in a way that it is subjected to the outside temperatures. And the temperature that if the whole thing is just sitting there waiting to come in to be processed, and you're under the hot sun, that obviously begins to affect the product. So that's one of the examples that we've seen.
Right. It could be temperature. It could be fluctuations in humidity that could throw things off. We're talking about potentially condensation, right? So you may have a lot of condensation on the equipment or on the product if in case of something like fruit being brought in from a hot outside environment into a cooled inside environment, right? You can have condensation on the fruit, which will introduce potentially extra water into the product. So there are many different things that can influence it. So it has to be something that plant managers and quality control people have a good check on to make sure that they do not influence quality, those environmental factors.
Yeah, so obviously this was a very good wrap up of everything that you've come across. Now, what are some specific situations that you've been involved in that help us understand how to get RFT right or otherwise?
Well, if you remember in one of our previous podcasts, we talked about lot control and we talked about different practices that plants utilize for lot numbering. And in particular, we were talking about date-based lots. When something is produced on a certain date, that date becomes the lot number. And one of the things we've run into with RFT is that when you're making a long production run that starts on one date and finishes on another date, and all along you're taking quality samples, then what may happen is that the lab says, okay, let's make sure that in that set of samples for that lot, for that storage tank where we were doing it, there is at least one approved sample. So that way we know that they might have had some issues along the way with the work in progress samples, but they ended up like with a good sample at the end. And so that's how some of them might search for whether they had RFT for that particular configuration or not. And what happens is your lot changes. So you were taking samples from the same physical production run, but when you were taking them yesterday, you recorded yesterday's date on your samples. When you're taking them today, you record today's date on your samples. So now when the lab finally approves the sample and says, yes, you've processed this enough, this looks good, that only applies to the latest date, right? So now you have everything you did yesterday that ends up not having an approved sample there potentially because you never got to that point yesterday. And now when you look at RFT, you're going to have lower score because there was something that you did yesterday that never resulted in anything good approved by the lab. You see what we're saying? So it's not really that they didn't do that run correctly. It is just an issue related to the lot numbering rule, to that whole date-based lot numbering that introduces headache and risk because it's just harder to manage than unique lot numbers that are sequence-based. So that's something that ties our discussion today with one of our previous episodes.
Lot control, exactly. Okay. Do you have any other stories in mind?
Yeah, we also see that RFT can be affected by how plants decide to work around reworks or adjustments that they make to the product. Sometimes not treating it properly and not classifying things as rework, or trying to make some small adjustment, at least in their mind. Sometimes it looks like, oh, it's just a small adjustment, it's nothing. Things like that can affect RFT, and obviously it comes out low, and then it's an endless conversation between different people or different plants potentially saying, well, we measure it this way, we don't account for this particular adjustment that we make, or this particular rework that we do. It's not really rework because we don't think it's rework. All of those things do come into play when you want to have a good, stable process of measuring a particular KPI, such as RFT in this case, right? You want to make sure that if you are applying certain set of rules, you apply them equally across all the plants. Now, if you decide to treat certain adjustments as still being right first time, that's okay, I guess, but you have to make sure that you treat it the same across all plants so that when you measure things, you're measuring it with the same ruler, basically.
What are some unique challenges when it comes to ODIF? Okay, so we've gone through right first time, and now it's the other big KPI?
So the top two that come to mind are the supply chain coordination and customer demand variability. And this is because in bulk liquid manufacturing, you have these specialized modes of transportation. So you have the tanker trucks, you have tanker rail cars, you have tanker ships that are used for large volumes of bulk liquids. And so there's a lot of coordination that needs to go into this. And frequently, companies sign up with a preferred in-house carrier that deals with this kind of transportation. But then, depending on the geographic location, there are some places where these carriers arrive by appointment. So they have a certain time when they have to come in and pick up an order and take it away. And you can imagine that if the plant is utilizing its storage tanks very efficiently, they need to make sure that whenever they made a certain product, it doesn't sit in that tank for too long. That if they contracted somebody to come in and pick it up at a certain time of day, then the production planner's already planning for the next batch that's going to go into that tank. So they need to remove that product on time. And what may happen is there could be some issues just because the driver has had a bad day for the truck, something broke down and he didn't come in on time. Or there could be just the customer calling last minute and saying, we really don't need that order today, we'll pick it up 2 days from now. And that messes up the schedule. And so now, when that happens, there is a certain churn in the system, in planning and delivery, that kind of has this domino effect that affects everything down the line, because now they need to reallocate resources. And so that has an impact on time and in full deliveries, mainly on the on-time part of it, because there's just delay introduced by changing things around. So that's the supply chain coordination and customer demand variability. And then you have other things like quality control. In some places, if something takes too long, again, I'm not talking about quality control in the sense of the lab doing its work and measuring, but more like built-in quality control into the process. So in some cases, there might be a product coming slightly out of spec and they need to readjust it. And until it's readjusted and in spec for that customer, they cannot ship it. So that introduces delays, certainly. And then the logistics of loading orders, that's the other thing that affects the in full component of OTIF. You have some people going through a very disciplined checklist and having the loading down to the science where they do it, and some just going willy-nilly about it. And it all goes back to what the expectations are for this kind of stuff, like what is considered in full.
Those are good points, but it's important to remember what on time in full is actually measuring and how all of these points really affect the two key measurement parts of the OTIF, which is on time and in full. The on time measure is really more so about the delivery happening on time as it reaches the customer. So the transportation part is very important. Obviously, you have some leeway in terms of how long it takes for the product to reach the customer. You may have a little bit of a buffer if it's a long trip, and maybe a smaller buffer if it's a short trip. But it's important that it's measuring the actual delivery at the customer to be on time, not necessarily when it leaves your plant. The in full part of it is obviously talking about how well you've met the actual ordered quantity expectation. So if the customer orders X and you're delivering Y, how far is the Y from the X? Usually, if it's within a few percentage points, it's considered to be good, but only a few percentage points. We're talking about 1-2% deviation. And again, depending on the overall amount. So if the amount is very large volume, then even a couple percentage point deviation might be a big deviation. So it's really important that it's close or very close to what the customer ordered. Sometimes delivering a little bit over the amount ordered may also be not great because it may not fit into the container that the customer expects the product to fit into. So under delivering and over delivering, both may be an issue. So you really have to get very close to the amount that was ordered to be considered making it good on the in full part. Now, of course, all of the points that we listed, they may affect the time of when the truck or rail car can leave the plant, but that trails and affects the actual delivery time as well at the customer. So you have to make sure that you're measuring your carrier's performance, the transportation carriers, to make sure that they do not underperform, that they are held to their specific contractual obligations to make sure that they deliver on time. So all of that together wraps up into this OTIF measurement and keeps your customers happy and the quality high.
Okay. And when it comes to either measuring the components that go into ODIF or managing these components, are you able to go to a new plant, look at their processes, look at their systems, and be able to determine with a certain degree of accuracy, like how much improvement the plant can expect just by having better information system and execution management? In other words, employing an MES. So are you able to look at a plant, study it, and then say, okay, I think we can give you a 9 to 15% lift in ODIF, for example?
Yes, so we can do that if we get the baseline data. So this is important. So when we look at what's happening, we would have to have the full cooperation from the local plant staff that would give us the data on their current state. So it's not enough to just walk around and look at things. We can certainly look at things and see inefficiencies, but to give you the delta, to say, you're here, we can take you here, without the details of the baseline, it's going to be only directional. It's going to be approximate. And Eugene, feel free to add to that.
Right. So whenever you want to improve any kind of measurement, be that RFT or OTIF, you do need to know, okay, where do you start from? Like, what is your starting point? And it's not enough to just say, well, tell me how you do things. You also have to make sure that some kind of data is already in consumable way that we can take and say, okay, what is your OEE? How loaded is your plant? Are you at capacity? How good are your carriers performing? Are they picking up on time? Are they delivering on time today, as of now? All of that is very important. Without all that data, it's very hard to say exactly how much can be made in terms of improvement.
Yeah.
One thing I want to say to that, there are two ways to go about it. And there's the short way, and then there's a long way. The short way is what Eugene is talking about, where we come in, we need some input from the plant management about their current issues, right? The long way is, okay, if we don't have any of that data, we can still give an answer. We can still give it with reasonable accuracy. But then it means that we need to collect that data. And if we're collecting that data, we could say, okay, so we're coming in, let's take a look at the orders that are going to be fulfilled from now until 3 months from now. And for 3 months, we collect the data and we see how many unsatisfied customers they've had with that. We see where they dropped the ball on RFT and things like that, and then we report back to them. So that's the longer way to do it, where if there's no data to start with, no baseline, then we can collect the baseline. But collecting the baseline means we need to observe their operations over a period of time. You cannot do it in a day, because how many orders are they going to fulfill in a day? You see, you need some volume to have that representative sample of the data.
And yet a third way that you could do it maybe is to say, okay, you know that you're running your plant not at a full capacity, so you have some spare capacity. You know that you could process more orders. So we're talking about directional, right? So you know directionally you could make more, you could ship more, you could do better on quality. Even with those vectors, you could say there's improvement to be had if you put the right tools in that will allow you to measure all of those data points. Then your actual time frame between knowing where you at and how much you can improve can be shortened if you have the right tools. So the data collection can be done by the actual system. So if you implement the system that has all those tools built in, that allows you to track all your deliveries and the quality and everything together in the system, it can be like a jump start. Even if you don't have the base numbers to begin with, you just directionally feel that, yes, there is room for improvement in all of those areas. We just don't have the measurements yet. You can still do it in a somewhat shortened time frame if you put the tools in. You have to trust, of course, that the tools will help you. And if you have that trust, then absolutely, you can put it in, and the system will allow you to get there faster.
Yeah, and because the reason for my question was that I know that like at least 90%, maybe even more, of our listeners are sitting right here and thinking to themselves, okay, exactly what you said, Eugene, like directionally, I know we can do better because stuff is being recorded on Post-it notes and Excel sheets. And like just right off the top of my head, I can name 15 inefficiencies that if we just tweak it a tiny bit, then the delta for the entire plant or the entire operation is going to go like through the roof, or at least substantially improve. And you know, I'm sure that at least 90% of our listeners are thinking that right now.
Yeah, and
then the second question that'll come.
Tools.
Yeah, they don't have the tools. So the logical question after that is, okay, if we start putting the right tools in place, what sort of delta can we expect on ODIF and right first time? And I bet it's like there's got to be 100,000 factors that go into this. But just out of your experience, because you've visited several of these plants and are working with quite a few plant managers on these sorts of projects, like what is a range that you could tell us, if it's even possible to give us a range?
So you are just introducing this and you're assuming that you have the plant management buy-in to go in and investigate, and the mindset of wanting to get better. So there's definitely room for improvement, because when you see low RFT, you have some easy wins and some harder ones, but it all goes back to the mindset of the plant managers wanting to improve their operation. And so some of it is easier stuff, some of it might cost a little bit to improve, but overall, if they're focused on continuous improvement, there is that opportunity. Absolutely.
It is a little harder to put a specific measure on OTIF. Like if you're tracking OTIF, all of a sudden, how much of an improvement can it make? But the real big issue with OTIF is that it can make your customers much happier even with small improvements. And your customer is ultimately the person paying your bills, right? It's the company paying your bills. So you really can achieve a lot with a little. When you look at your OTIF measure and you improve that by even a few percentage point, 5 maybe percent or 10%, the actual improvement in overall business might be much bigger. It's like a small wave that leads to a tsunami, basically. It's really impactful that the customers are all of a sudden much happier with your delivery schedule, with how good you are, even if it's a small improvement in that measurement.
Yeah. So it's a huge point of leverage, right? So you
Yes.
tweak it by, I don't know, 5%, 4 percentage points, but it makes a huge impact across the board, across the organization, and in customer happiness.
And
Yeah.
then you reel in the OEE into this and look not just the RTF and OTIF, but also at OE measurement, and you have a system that can help you with all processes that involved in all of the three. You can expect really good improvements there.
Just to add a real anecdote to the OTIF conversation. So, what happens is that these big customers of bulk liquid manufacturing factories, they have certain changes every once in a while. So it might be an example where there was an unexpected market event, like that shortage with baby formula that happened in the United States not too long ago. You have different things happening. You have some hurricanes that disrupt the supply and may knock out some of the existing arrangements, where all of a sudden a certain supplier cannot produce the same volume of product for a foreseeable time. And so what happens then is that these major consumers of this product will evaluate their business and say, okay, for the time being, maybe we want to switch to another supplier, to a competitor of yours, and use them. And so what we've seen and heard is that this OTIF improvement actually helps you maintain your reputation, so that when such adverse events take place in the market, those big buyers, they want to run to you over the competitor. So that's what Eugene was saying. Like, it might be 4 or 5%, 10%, but if you use OTIF to get great reputation, whenever there is a next market disruption, they're going to come to you and say, are you able to produce this much more? Do you have the capacity to give me what I need? And you'll be one of the first ones to hear about it if your OTIF is great. So that's where that really helps.
So there's a lot that we covered. And just to wrap up, can you sort of summarize the recommendations that you have for plant managers who want to stay on top of their RFT and ODIF numbers?
Yes, absolutely. So would say focus on the customer feedback. Voice of the customer will always guide you to the right priorities. So if you listen to the customer, it will help align the initiatives that you need to work on at the plant to make sure that you are delivering the most value, because the value is the value for the customer, right? And then second, invest into employee training. So you want to make sure that the staff is not only trained to do their jobs, but that they are motivated, that they're encouraged to speak up and feel like they're part owners of the business. That way they will speak up whenever there are improvement opportunities, which you might never hear about unless they tell you. So that's very important. Third one is invest into robust quality management systems. And we're talking about revising your standard operating procedures, getting some tools. Of course, things like MES systems would help. There are different software solutions that could help in this area, but you want to make sure that you are producing quality product consistently, because that will play into your reputation with the customer. And then focus on continuous improvement. So going back to that mindset, if you have the mindset of continuous improvement, you'll seek out opportunities to do better, and you'll be good in the competitive landscape. And then lastly, leverage technology to gather and analyze data from the machines. So that's what the whole Industry 4.0 conversation is about. You want to make sure that you're not only collecting data from your operators that they manually input, but you want to have the sensors, and you want to read from the sensors, get reliable data back, and make informed decisions.
Thank you so much, gentlemen. That was another deep dive. And for you listeners or watchers of us, you might want to go back to a couple of these parts because it was, in fact, pretty dense in some places. And what we can promise you is that down the line, we have already started working on assembling everything that we've been covering so far in the recent episodes, because what we talked about is a lot easier to put into practice and even to comprehend when you see it in a document. So that is coming your way. I just want to tease that a little bit, just so that we spark your curiosity somewhat. So be expecting that in a short while from Eugene and the Efficiency Equation podcast. And until the next episode, have a good time and happy managing. Bye-bye.
Thank you, Dan.
Thank you.